Hello, and thank you for listening to Renewables, a podcast by BioStar, which aims to explore the current and future energy landscape in America.
Welcome back, everybody, to another episode of Renewables. I'm David Smart, your host, and we're very pleased and excited to have Bill Smith with us this week to talk about XcelPlus International, a company which he founded and still advises. Bill, thank you so much for coming on the show. There's a lot to unpack today. Fantastic company that you have and a technology that has so many different applications. Really look forward to digging into that. Thank you for being here.
Appreciate it. Glad to be on.
Great. Well,
dig in.
Yeah, we can dig right in. Tell our viewers and listeners a little bit about your background, how you ended up founding XcelPlus International and your path, and we'll go from there.
So I started XcelPlus back in the early 2000s as a specialty chemicals and lubricants company. Found a line of products that would reduce friction, reduce energy. U.S. Department of Energy said it would cut fuel consumption by like 100 million barrels of fuel a year. So I started out peddling that out of the trunk of my car and built it into offices in Shanghai, Bangkok, and Singapore. And then we kept looking for technologies that would help cut fuel costs and savings and productions and emissions and all that good junk. And wound up in Brazil buying a technology that we could mount it on your car in a few minutes, and your car could run on ethanol as well as gasoline seamlessly, like a flex fuel vehicle. Built that up quite a bit, did some conversions for the Air Force and stuff. Then when Katrina hit, we'd already been looking into gasification as a way to take waste streams and turn them into a gas called Syngas, and then take that Syngas and either run generators or run it through what's called a Fischer-Tropsch system and convert that Syngas into synthetic diesel fuels and gasolines and jet fuels that are cleaner than petroleum-based fuels. The problem was it didn't exist. We couldn't find a gasifier that was portable. I mean, we could find some at $72 million that were in huge buildings, but because of Katrina, we're like, can we move something into town, grind up all these trees, houses, whatever, and turn them into energy to get them back on the grid and get fuel back in the area? So pretty much XcelPlus went dormant around 2008 because industry shifted. People realized they didn't really want renewables. They like petroleum. And in 2017, I'm out in California and I set up a company and I gave out 2 business cards. This guy calls me and goes, "Why do I have your card?" I'm like, "I don't know. Why do I have your card?" I'm like, "I don't know. Who the hell are you?" He said, "My name's Christian Juvan." I said, "So what?" He said, "Google me." Well, it turns out he's the grandfather of plasma physics. And he had helped start a company that turned garbage into energy. So we got to talking and tried to acquire their company in 2017, but they had a shareholder who passed away, and his estate was like, yeah, no. And finally, they're like, "We're going to sue everybody invested in." So my attorney said, "Just walk away." Fast forward again to 2020, I approached some of the major shareholders of the company, said, "Would you guys be interested in swapping your stock for publicly traded stock?" And they're like, "Sure." So we started acquiring the stock and the patents and the IP. And around February this year, we engaged a bunch of engineers to take the gasifier and change it from 25 tons a day to 50 tons a day and still make it transportable. So that's how we arrived at where we're at today, which is a gasifier that will take 50 tons of garbage, waste coal, sludge, sewage, everything but nuclear waste, and convert it to syngas so that we can produce, in some cases, power and electricity for crypto miners, to the grid, to diesel fuels, jet fuels, clean hydrogen for the new rail systems coming out. And we're at the point of launching all that out right now. So that's how we got here.
Yeah, it's really interesting. And dig in a little bit further to like what types of products do you actually make with this gasification process? And on your website, and we talked about a lot of different applications for this type of technology, but uh, dig into the process a little bit more.
Sure. So the shirt you're wearing, the uh, chair behind you, the carpeting you're sitting on, wood products, garbage from landfills are all made of molecules. And basically, gasification is a process called molecular dissociation, where you take these molecules and tear them back apart into sometimes individual atoms like hydrogen, nitrogen, carbon, sulfur, potassium, phosphorus, whatever. And then we take those same molecules, rearrange them, and create what's called syngas, which is carbon monoxide, carbon dioxide, and hydrogen. So it has a BTU caloric value to such that we can put this in a GE turbine and put out as much as 30 megawatts if we couple some of our units together. We can put them in smaller gen sets and do 5 megawatts. We can run it, you could run it in a car engine if you wanted to. So it's a basic building block for many things. When Germany fought the war, they gasified coal into synthetic diesel fuels, which that technology was then brought to the US. So we can take that same syngas or run it through a catalyst, and out comes diesel fuel. And you can build enough fuels, I believe, globally from waste to power the world. And then if we strip or add waters to our gasifier, we can phase shift it and create pure hydrogen. So it's another way to form hydrogen than electrolysis, which our process is cleaner because at the same time we're getting rid of waste streams like landfills, waste coal piles, and things like that. Yeah. So rip molecules apart and put them back together differently. That's the Reader's Digest version.
Yeah, that's a good way to put it, and appreciate being able to the good examples for our listeners and viewers who might not be as tuned into this type of technology. We talked about before the call a big list of applications for this.
Sure.
So I want to go there for a minute, and then I want to come back to hydrogen, because hydrogen certainly is kind of all the buzz right now,
right.
and definitely a big part of the future of storage, at least a lot of people believe, and so want to explore that. But you talk about disaster relief. We're actually recording this in early September as Hurricane Ida has gone through and obviously created a lot of damage. Yeah. In Louisiana, and that's one application that is particularly interesting because of, as you discussed earlier, the mobility of the product.
Right.
But what about for more permanent installations? Talk about some of the applications that you see this technology being able to go in and really disrupt and replace.
So the whole premise we started with was portability, and we're actually going into manufacturing now of these gasifiers, but we could actually ship this thing on the back of a flatbed truck to Louisiana, Puerto Rico. Well, you need a boat there, but anywhere in the world. And within a couple of days, set this machine up and start grinding up the waste, trees, old houses, just take cars and take the auto fluff out, and then feed it to our gasifiers and produce this syngas. So that's one application, and we're looking at a company that does this for FEMA now, so it's easier to add our technology to them. On a more permanent basis, we've identified several hundred landfills here in Texas that are closed. So one of the models we're about to ramp up is we go to an old landfill, we take the dirt off the top, we start taking all the garbage out, we shred it up, feed it through our gasifiers, and we produce power that we can either put on the grid or produce fuels to go to distributors of fuels around the country. And we could produce hydrogen for example, like if along the interstates, we could take every landfill along the interstate and produce hydrogen to fuel up hydrogen cars, which right now you only do in Texas. In California. So our model is to take a eyesore, a pollutant, and turn it into a positive.
Sure.
So if you take a landfill that has several hundred million or several million tons of waste in it, we get rid of the total ability to generate methane by getting rid of the landfill. And the same thing, we're looking at a project in Pennsylvania with 120 million tons of waste coal. And right now, when it rains, the water goes through the waste coal and pollutes the rivers and kills rivers. So we're actually looking to go in and take those coal piles, turn them into energy. In one case, we have crypto miners who want to buy all the power from us. So we can turn this waste product into a fuel for crypto mining. So on a permanent basis, we'll build these all across the world. So
sure. No, there's a lot of different applications, certainly, that you can come up with. The landfill is super interesting. At BioStar, we develop waste to energy projects, and we're really focused on organic waste because we make an organic fertilizer from the effluent waste off the back ends of those digesters. But so we're especially tuned into a lot of the landfill diversion laws that have been, passed recently in states around the country, most notably California, and sort of where that, the country and really the world has a landfill problem, a waste problem. And so technologies like this, I truly believe are going to be so important. While organic waste does make up a pretty good chunk, there's a lot of other stuff left over, and the coal waste, of course, is super interesting because you're basically taking something that's hazardous and being able to recycle it into energy. So that's super interesting. I think you mentioned also that you're converting into diesel and diesel renewable jet fuel. We're seeing airlines announcing all sorts of really ambitious net zero goals and greenhouse gas reduction goals. So it's an interesting market to follow as well. That renewable diesel or renewable jet fuel, I think, is a space that we'll see a lot of growth over the next decade.
And to think this is all brand new 1920s technology. When they converted coal into syngas, that's how the Germans powered their tanks, ships, everything. Texas A&M University received all that after the war and offered it to the oil companies who are like, nah, we're good. As long as crude oil is under $35 a barrel, crude oil production into fuels is cheaper than synthetic fuels. So it died for years. And, I was doing all this research. I'm like, well, why aren't we doing this? So there were two components we needed. One is the way to gasify the waste. And the second process was to convert that syngas into liquid fuels. It's called GTL, or gas to liquids. And we found a company up in Sacramento that has a modular system that fits in the back of shipping containers. And we literally can feed our syngas in there, send it to the other end, and get diesel fuel, jet fuel. The catalysts determine the fuels because it rearranges the hydrocarbons into various forms. So you either get gas components for gasolines or diesel fuels or jet fuels. So it's really interesting science.
Yeah, absolutely. What's before we jump into hydrogen, what's a typical payback? I know there's different applications, and different applications have different needs, obviously, and ways they determine payback. But what's a typical payback for one of your 50-ton units?
With the tax credits, the incentives on federal and state levels, and the energy prices today, 2 to 3 years, especially if we use what's called an organic Rankine cycle, which is the syngas goes into a jet engine to produce power, like 3 megawatts, and then the heat goes over into what's called an ORC system, and it takes that heat and converts it into 1.5 megawatts. and that places our output waste stream at 99.99% clean. And we're dumping out 5 megawatts. And in some cases, payback's like 2 years.
Wow. So
the systems last for 20.
Yeah.
Right.
That's amazing. That's pretty fast. So let's move into hydrogen. Talk about, kind of how your technology plays into the future of hydrogen and why this is so important.
So Syngas has one major component: gasoline, diesel fuel, jet fuel, propane, methane. All of these fuels have one component in common: hydrogen. So when we're running gasoline in our cars, it's the hydrogen that's actually doing the burning, load carrying part of the process. And the other molecules retard or increase the flame rate, which means, you might not use propane in your car as fast as gasoline because the gasoline needs to be slowed down to a flame rate that would work in internal combustion engines. So what we can do is we can actually water phase shift within our reactor by adding in water or paints or other liquid waste and increase the hydrogen output. We have a company up in New York we're actually working right now in a joint venture with them for a project in Louisiana to convert 1 million tons of sugarcane bagasse into pure hydrogen. And they have a industrial/government contractor wanting all the hydrogen. So we're actually wrapping that and taking it to contract here in the next few weeks. And that'll be a pure hydrogen play. And when we can prove that model out with them, we're looking to go to the railroads and take landfills all along the railroad lines and start producing hydrogen for them, or along the interstates and produce hydrogen for cars. Because if you own a hydrogen vehicle today, where do you get your fuel at? Only state's California. So we believe we could help open up the nation to hydrogen fueling systems by taking the landfills and producing hydrogen for cars or trains or trucks. So
that's fantastic. I really look forward to following along with the company and monitoring your progress. You have a great website, XcelPlusInt.com, and there's a lot of great information on there. What else do our viewers and listeners need to know, and how can they find more information out from the company or from you if they're listening and want to get in touch?
Well, we're a small publicly traded company. We're looking to move up in the world in the stock markets, but we're also, like you said, through our website. We put out press releases all the time when we're doing changes in the company, which we're required to do. But we're also starting a blog to put information out that'll go out through the channels, or our IR PR guys doing that. But mostly what we're looking at is, our world is getting smaller and the people pile is getting bigger. And, everybody wants to conserve energy, help the environment. And one of the things we found out is it's really not working. Remember all the plastics we were shipping to China? China sent it back and said, no, good, we'll pass. So in that, we'll be putting together a system where instead of that plastic being baled or landfilled, we'll actually be turning it into fuel or energy that's useful for the world. We're also down the road, we're putting a project together to mount some of this technology onto supply ships, and we can go out and collect up garbage in the oceans and convert it into fuel right on the ship. So we're not even using petroleum to go out and collect the waste, and we're not using petroleum to move our commodities around. And then we would go into other smaller nations, Vietnam, Cambodia, China, Indonesia, places like that, and take these small units we have and place them on land, and they can bring all their plastics and trash there, and then we can turn it into fuel for their communities and into Syngas to put power out on the grid for their villages as well. So, we're looking to take this thing out to a global scale, and I'd say mostly just keep watching the news, because we're going to keep rising to the top of the things we're doing.
That's great. Well, we look forward to following along, and hope you'll come back on the show and keep us updated on how things are going. Bill Smith, founder and advisor to XcelPlus International. That's XcelPlusInt.com. Thanks again for coming on the show. This has been another episode of Renewables. Please make sure to follow along, give us a like, give us a follow wherever you listen to your podcasts. And Bill, thanks again and come back soon.
Thank you, sir. Appreciate it.
Thank you.
All right.
Hello, and thank you for listening to Renewables, a podcast by BioStar, which aims to explore the current and future energy landscape in America.